All right, so we've already seen how to work with truth tables for negations, conjunctions, and disjunctions. Now we're going to move into conditionals and biconditionals. If you're reading ahead here, don't laugh too hard. The statement I have, kind of interesting. If you pee on the potty, then you get a gummy bear. So, a little story behind that. My wife and I are potty training our 2-year-old, and this is actually one way that we're getting her to do that, a little reward system. I'm sure there are better ways to do this, but it's working for her. So anyway, she loves gummy bears, and she doesn't get them very often, or any sort of sweets really. So it's a little perk, encouraging her to go to the bathroom. So anyway, but it is a conditional statement. If you pee on the potty, then you get a gummy bear, and there's variations, how much we give her based upon different things, but I won't get into the details. Anyway, so it is a conditional statement, and it does kind of fit what we're looking for here. So what we're going to do, the simple statement, you pee on the potty, is one, I could represent that with P. That makes sense. P on the potty. Anyway, and get a gummy bear, we could represent that with Q. I didn't plan that anyway. So if you pee on the potty, then you get a gummy bear. So that's our if P then Q. Symbolically, we would write that P implies Q. Okay. So what we want to do then is try to figure out the truth value of that statement. Okay. Whether that's true or false, based upon whether P is true or whether Q is true. Did she pee on the potty? Did she not pee on the potty? Did she get a gummy bear? Did she not get a gummy bear? Okay. So we're going to do that. We're going to first establish P and Q separately. And this really doesn't start out any different than with negations and conjunctions and disjunctions. It's going to start the same. You've got two statements, so you have 2 to the 2 power options, which is 4 again. We set it up true, true, false, false, and then true, false, true, false, and that gets us all of our 4 possible combinations for those 2 statements. However, then you got to think about what do we have if we use a conditional here? In other words, when is a conditional true and when is a conditional false? If we think about it, the conditional only really makes sense if the first part is true. Now we also have names for these in the first part, second part, better names. They're called the antecedent. Okay, so the first part, the P is the I'm not even sure I can spell antecedent. A-N-T-I-C-E. I'm going to cheat. D-E-N-T? Oh, ante. It's A-N-T-E. C-E-D-E-N-T. So P, is the antecedent, and Q is the consequent. Think of it as a consequence, right? Getting a gummy bear is a consequence for peeing on the potty, right? A consequence. Usually we think of that as in a negative connotation, but really it could be positive too. Consequent is just a consequence. Consequent, yeah. So we have the antecedent and the consequent of the sentence. Okay, so the truth of the statement really depends upon whether or not the antecedent and consequence are true. But the statement itself really only makes much sense if the antecedent is true. So let's take this example. If both are true, if it's true that she peed on the potty and she got the gummy bear, right? Pee on the potty, do the gummy bear, then the conditional statement is true, right? I did what I said I would do. I didn't lie, all right? So 2 truths make a true. That would make sense. The next one, if she peed on the potty but I did not give her the gummy bear, that would be bad, right? Bad on my part. Then I'd be lying, right? I would have said a conditional statement. If you pee on the potty, then you get a gummy bear. If she pees on the potty, I don't give the gummy bear. That's bad. So that's false. That makes, if that were what I did, that would make the conditional statement false, okay? And then she wouldn't be trusting me, right? That would be bad. Now let's say I gave this statement, if you pee on the potty, then you get a gummy bear, and she never peed on the potty. Just didn't do it. No peeing on the potty. Then, let's say she didn't pee on the potty, but I still gave her a gummy bear. Is that wrong? Well, no, maybe I gave her a gummy bear for something else. You know, who knows? Maybe I was just being generous one day. Maybe I have other conditional statements in our household where she gets gummy bears for other things, right? So I didn't break my word by giving her a gummy bear. If she didn't pee on the potty, I didn't do anything wrong there. There may be good reason why I did, right? So we would actually say that that's true, which is weird. If she didn't pee on the potty, but I gave her the gummy bear, gave her a gummy bear anyway, that my statement didn't have anything to do with her not peeing in the potty, so I didn't say what would happen, you know. And here, again, if she didn't pee on the potty and she didn't get a gummy bear, well, that kind of makes sense too, right? That's a possibility. You know, if she didn't, you know, maybe that's the only reason she would be getting a gummy bear, right? And so we don't know. This statement doesn't tell us anything about what happens if she doesn't pee on the potty, right? So I haven't broken my word if I withhold the gummy bear. I also haven't broken my word if I give her the gummy bear if she doesn't pee on the potty. So in that case, because I haven't broken my word, I haven't lied, we would say the conditional statement is still true, right? I haven't said anything wrong. So the only time that a conditional statement is false is if the antecedent is true, but the consequent is false, okay? You don't follow through. And so that results in a false statement, okay? Everything else is true, which is kind of interesting. So you get 3 true statements and 1 false, and the only false occurs when you have a true antecedent and a false consequent. Okay, so that's just a basic setup. Now, it kind of makes sense for this particular example, but it's true for all conditional statements. Conditional statements work, they're equivalent, they work the same. So it doesn't matter what the P and the Q are. I just use it as kind of an entertaining example. But it doesn't matter what the P and the Q are. They can be anything. You know, if the clouds are dark, it's going to rain, then it's going to rain, something like that. So then you can set up a similar truth table. If the sky is dark, then it rains, you get a true statement, then that statement was true. If the sky is dark and it doesn't rain, then the statement was false. If the sky is dark and then if the sky is light and then it rains, well, the original statement was still true because it doesn't say anything about whether the sky was light or not, or what happens when the sky is light, I should say. If the sky is light and it doesn't rain, then the original statement was still true. It didn't really apply, but you weren't lying. You didn't do anything wrong. It's still a true statement because it kind of doesn't apply there. It wasn't proven false. Okay. Okay. Now we can also look at some other combinations. We could look at maybe the negation, conditionals with negations, what happens there. So we could say, what about the statement, not P implies Q. So if you don't pee on the potty, then you get a gummy bear. Okay, well that's kind of not serving the purpose I wanted to. But let's just say, for instance, that we have a situation like this. What would the truth table look like? I'm only really interested in the truth table. This example is just here for entertainment value. So not P implies Q. Well, what we need to do is set up our truth table, set up our P and Q, which will again look exactly the same. true, true, false, false, true, false, true, false. You guys will do this 100 times in the homework. Okay, not 100, but a lot of times in the homework, and you may get sick of it, but you'll know how to do this, right? Then you have the not P, which is the negation of the trues and negation of the false. So it's the opposite, right? False, false, true, true. And then you have the implication here. So you have not P implies Q. And remember, when you're looking at a conditional statement, it's only false when the antecedent is true and the consequent is false. So look at this, the antecedent is listed here. I need that to be true, one of these two, and I need the consequent to be false. So that happens here. True antecedent, false consequent. Now they're in the table, they're in reverse order. That just is because of the order in which I listed them. What's really important is how they relate to the arrow, right? The antecedent comes first, the consequent comes second. So I want true antecedent, false consequent. That results in a false conditional statement. Everything else is true. So as long as the antecedent is false, the statement is true, and as long as both are true, the conditional statement is true. Okay? So we get 3 trues and a false there as well. And we can combine these in any way, but you kind of get the feel for it now. I could do not P implies not Q implies P, lots of different combinations. If I give you a gummy bear, then you don't go potty. I don't know, whatever. There are times where those things make sense, and in this case, maybe it doesn't make much sense. But again, it's the options that are important. The actual statement is just kind of there for entertainment value.